So this is going to cover how to find water and attempt to purify and filter water during a nuclear crisis. This is essentially part 3. There's part 1 and a part 2. And so we're going to go over water. What I'm going to start off with is the attempt to remove and purify water. And at the end, we'll go over ways to find indoor and outdoor water sources. So in terms of radiation removal, the main ways to remove radiation from water are reverse osmosis, activated carbon, and ion exchange, lime softening, distillation, filtration through carbon and soil. So here's information on how reverse osmosis works. Essentially, you would need some type of equipment in order to accomplish this. They do sell affordable countertop versions of this. Most effectively would be actually in a laboratory. If you're interested in reading some articles or websites on how that works, you can. Next would be activated charcoal that people use in filters. So you've seen those countertop pitchers with the charcoal filters in them. The only problem with, one of the problems with that is that at a certain point, the filter is going to be full. It's going to stop working, and you have to replace the filter. So the question you need to ask is, how much radiation can your countertop filter actually filter out before it needs to be replaced? And so then there's some other information on how radiation cartridge would work. Most of the ones that you would purchase would have several different layers and types of filters, and it's going through a process that's going to filter it over and over again, like with activated carbon and ion exchange. And you can read, this is an article from Forbes.com, and it kind of goes over the basics of it. So it goes over reverse osmosis, activated carbon to remove the iodine, and then also ion exchange using water softeners and so forth. And so you can look at this Forbes article, or you can look at various websites on these different topics if you're interested. Reverse osmosis uses Gore-Tex fabric, and it is the most often mentioned way to keep radioactive plutonium and strontium out of drinking water. Like I said, you probably do need special equipment for that. As you can see, they do sell these things on Amazon around $200 some odd, where there's 5 stages of water filtration and so forth. But obviously this film is mostly directed towards people who are currently in a crisis, so I'm not going to emphasize preparation so much as what to do in the situation. There's also an article down here that you can take a look at. I'll go over that at the end. And you can also look at reverse osmosis information from North Dakota State University and the U.S. Department of Agriculture. I think this is it over here, unless I'm mistaken, yes. So this article is from their library, ag.ndsu.edu, and then you search their publications area for the title of this article, Reverse Osmosis, It's All in Your Water, the 2013 edition. WQ 1047. So what I really wanted to go over was distillation, because without equipment, in the previous films or audio recordings, I emphasized filtering and settling, so I also wanted to emphasize distillation. It is a way that you may remove some radiation from water. From the Department of Energy, I had read several articles that really did not state unequivocally, this removes all the radiation. But when I've looked at websites, I've seen many people state, this is the way, this is how you should do it, like listservs and message boards, where you're not necessarily talking to an expert. So I did want to try to track it down. And so the question here to these experts at the Department of Energy, U.S. Department of Energy Office of Science. So here's the question. Radioactive water. If you have radioactive water and distill it, if the water was not radioactive but had a radiochemical mineral dissolved in it, will the distilled water minus that radioactive element be radioactive, or is there a chance that it will be radiation free? And is there any surefire a surefire way for removing all radiation from water. And here are the replies. The first one is from Richard Behrens, PhD, Master's of Education, Department of Physics and Astronomy. So it depends on what the contaminant is. And part of the problem is that radioactive waste usually contains many different elements, each with unique properties. Some of the really bad actors like cobalt, plutonium, cesium, and strontium do not form compounds with high volatility, so they will not go into the vapor phase, and theoretically will be left behind in the pot in a distillation. In practice, however, distillation involves boiling, which produces aerosols. Some of these may be carried into the collector. Different ways of running the distillation can increase or decrease the extent to which this happens. In many cases, major proportions of the radioactive contaminants can be removed by ion exchange or reverse osmosis. But what fraction of residue is low enough? Some contaminants such as radon and iodine will not necessarily be removed by simple distillation of the water. More complex distillations can do better, but exactly what is best to do depends on the specific situation. Basically, distillation will probably remove a lot of the radioactive contamination from water. Whether or not the distilled water is safe to drink will depend on how much radioactivity is left and what your standards of safety are. Do not forget that all of us are daily exposed to ionizing radiation from natural and man-made sources. Your distilled water will not be radiation-free, per se, but then again, water from a pristine mountain stream is not radiation-free either, and it would not have been even before humans discovered radioactivity. So to recap, essentially, he says that basically distillation will probably remove a lot of the radioactive contamination from the water, but it's just not guaranteed. It just depends on what type of radiation it is. We do have a second answer from Vince Calder. If you have radioactive water, it depends on the amount and the source of the radioactivity. Alpha particles and beta particles, gamma radiation, and mixtures of these. It also depends on the chemical form in which the radioactivity is present. They could be various elements and so forth, as well as compounds. So you can't just assume the radioactivity comes from some mineral that remains resolved in the distillation pot. In principle, you could separate the radioactive mineral from the water, but at a large energy cost. The heat of vaporization of water requires a lot of energy. So even if it works on paper, it does not mean it's feasible on a large scale. It's not an easy solution. However, I want to reiterate that the general consensus seems to be that distillation would remove a lot of the radioactive contamination from water. It simply is not a guaranteed method. In this situation, probably nothing is going to be a guaranteed method. There are a number of different ways to distill. I imagine that most people are going to be using stove heat. I tried to find an example with a lot of visuals. I apologize if you are sight impaired, but the wikihow.com/make distilled water has a good visual, and there are a couple other websites that have the good visual as well. And see, it's very easy to make. You can do that at home, or basically if you had a campfire. So you have a stainless steel pot halfway full with tap water, maybe a 5-gallon pot. You place a glass bowl in the water, make sure that it floats, and the bowl should not touch the bottom of the pot, so if you need to put like a little rack under it or something like that. If the bowl doesn't float, remove it from the water and set a round baking rack on the bottom of the pot. Then place the bowl back in the water, and then you watch the water collecting in the bowl. This water should be hot, but it should not boil. If the water begins to boil, turn down the heat on the stove. And then you put the lid on top of the pot upside down, and you put ice cubes on top of the lid because you're creating the condensation effect with the hot-cold barrier. When hot steam hits the cold lid, it will create a condensation. And then you boil the water in your pot. And as the water continues to boil, it will cause steam to rise and condense on the pot's lid, which is upside down. Then it will drip down into the bowl in the middle. So the water's down in the bottom of the pot, and the bowl had no water in it. And then the condensation accumulates on the lid, and the knob in the middle of the lid creates a a point in the middle so that it drips down specifically into the bowl, which is in the middle. Of course, continue that until you have enough water for your needs. Then you remove the pot from the heat and you take off the lid. You take the bowl of distilled water out of the pot of boiling water, using caution not to burn yourself, and then allow the distilled water, to cool before storing it. And then there's some information about bottles and so forth. There are a lot of YouTube videos about this as well, if you want to look one up. Here's one right here. So that's information about distilling on a stove. There's also atmospheric water generators, bottles, and solar still. So the atmospheric water generator, this is a do-it-yourself website on how to build one. I'm kind of assuming you're not going to have these parts just lying around, but I did link into it. It's on instructables.com /ID/DIY atmospheric water generator with dashes. So essentially, if you wanted to build one of those, you could. There's a way to do that with bottles, and there's one for solar still. Essentially, this is kind of helping. We'll do this one, and essentially, here's some pictures. If you are watching something, there's pictures here. You're kind of digging a hole in the ground, and then you put your container in the middle of the hole, and then you put the plastic on top so that it's sort of drawing the moisture out of the soil, and it accumulates on the plastic tarp, and then you have like a rock in the middle of the tarp that creates a point that makes it go into the cup that you've got, and you're supposed to suck that out of the cup with a straw. So that is another way of distillation. So essentially, distillation is recommended, but not guaranteed 100% as a good way of removing radiation. The other ways that we have already covered would be filtering through dense clay or earth, settling, which is again mixing clay and water and letting the clay settle to the bottom so that it's and then you dip the water out from the top, so it's, you know, kind of attaching the earth to the larger particles of radiation. And where that information, primarily, I've seen that on a number of different sites, but a lot of that information came from the Nuclear War Survival Skills book. And so if you wanted more information about that, that chapter, which is chapter 8, has a lot of information about carrying water, you know, how to carry water, how to store water, siphoning. If you have your water in a plastic bag, instead of trying to pour it out of the top of the plastic bag, you should siphon it out with a tube so that you're not manipulating a huge plastic bag full of water, and spilling it. And then disinfecting water, sources of water, and so forth. So there's a lot of information on that particular website. I will go through the two ways, the filtering and settling. So from the top layer downwards, you get a container, like a hanging plastic file case or something like that. So on the top is water, then a layer of porous fabric, then 6 to 7 inches of clay soil, another layer of fabric, 1.5 inches of pebbles, and then you would prop that up with sticks or what have you, and then put a pan under it to catch the filtered water. It's very basic. It's not guaranteed. In fact, most of the research that I read does not mention this. It's called soil aquifer treatment. It is a legitimate means to remove like E. coli and so forth from water in places that don't have a purification system in place. It's typically not used for removing radiation, but it is mentioned by survivalists as one method. So then the second method, settling, is you fill a bucket 3/4 full with water. You dig up clay from 4 or more inches under the ground and mix it with the water. 1 inch of clay for every 4 inches of water. Let settle for 6 hours and then siphon or dip the water out. You do want to think about with that, I'm thinking, what if somebody has a house plant and they're using that? You want to think about whether you've put additives into the soil, like Miracle Grow, things like that. And just kind of be mindful about other things that can be in soil that could potentially be harmful. So to recap, the other ways to remove radiation from water would be ion exchanger, water softener, cation exchanger, lime softening, gravity type tabletop canisters with charcoal filter system. When you're done with that, you should actually also strain it through a coffee filter so that you're not consuming small particles of charcoal and so forth. And the percolation of water by distillation, which we just went over. You can fact check on the EPA website, and also you can look up articles on soil aquifer treatment to decide whether you want to go with that method. Probably distillation would be your first choice if you just have a kitchen to deal with and no laboratory and so forth. So there are some articles here on ibiblio.org/rcip/nuclear.html if you wanted to look at some of the research that I've attempted to link into to give you information. And as I said, there are filters if you are doing research ahead of time before the disaster occurs. Here are some that are like $1,000, $250, and so forth that you can get for your home. There's $200 and $300 ones that you can get from your home that would be helpful in that regard. So after that point, after you've filtered, you do want to purify your water no matter what. I want to emphasize that boiling will not remove radiation. So here are some ways to purify water. Essentially, boiling for 3 to 5 minutes, and of course collecting any evaporated water. Definitely let it cool before drinking. If it tastes really terrible, if you pour it back and forth between 2 containers, it does add the oxygen back in. It tastes better, but you have to think about whether you're exposing it to radioactive dust or not. You can also add 4 drops of household bleach with 5.25 sodium hypochlorite per quart of water. Don't use scented or color-safe bleaches. Let it stand for 30 minutes, and it may have a slight bleach odor. Of course, we already discussed distillation. So to finish up, we're going to go back over the sources of found water. So indoor water sources. Do not drink water from open water sources. Some researchers feel that water coming from a pipe underground during the first few hours may be safe if the pipes had not yet been contaminated. It should be collected and stored in clean containers. And one of the sources of that, I've read that from several different sources, and one of the sources of that is from Radiologic Emergency Protecting School Children in the Public by Harrison, Gustafson, and Dixon. So possible sources of water inside a shelter would be melted ice cubes, liquids from canned goods, water heater. Be sure the electricity or gas is off, and that you have somebody, an expert, or reading instructions on how to open the drain at the bottom of the tank. Being careful not to burn yourself or explode anything. Pipes, covered tanks. Some experts feel that water from toilet tanks, not the bowl, is either a last resort or else not safe for consumption. A lot of the survival websites will encourage the use of water from toilet tanks, but I found that most of the experts and government websites do not encourage it. So water from all sources should be purified, as I mentioned before use. Consult an expert for instructions on how to safely access your water heater if you choose to. There are, some websites, obviously, on how to clean your hot water heater and so forth. One thing that has been emphasized is make sure that it's not damaged. You're not drinking water from a damaged water heater. So you can look that up. So getreadygear.com/clean hot water heater is one website. If you want to Google that, you'll probably come up with that website. Both FEMA and ready.gov do claim that water from toilet tanks, radiators, hot water boilers, home heating systems, water beds, swimming pools, and spas are not safe water sources so those were not safe. I do want to make sure I make the distinction between a hot water heater, and a hot water boiler, because I know in some parts of the South we don't have radiators necessarily. So a water heater is different than a hot water boiler, which is essentially a radiator. And you can find information about that at the radiantech.com website. And there are illustrations of the difference between the two of them. And the radiator is often also called a home heating system. So one of the people who encouraged the use of the water in a toilet tank, not a bowl, would be the State of Louisiana website, and also most survival websites encourage that as well. Outdoor water sources would be cited by nuclear war survival skills would be water from deep wells and from water tanks and covered reservoirs into which no fallout particles or fallout contaminated water has been introduced, and also water from covered seepage pits or shallow hand-dug wells. The earth is not sandy, gravelly, or too porous. Filtration through earth is very effective. And I believe that's from around 1987, that book. And also the SAS Survival Handbook cites underground wells and springs, water in pipes and containers, and fast-flowing rivers. So we've already covered radiation removal. To recap, probably the best thing for you to do would be to accumulate water from all the sources that you can. Find safe ways to store them. Keep in mind, if you're storing water in a plastic bag, that bag might spring a leak during the night, so you want to make sure you have that inside of something else waterproof, like store those bags inside of a bathtub or something like that. And make sure you've plugged the bathtub thoroughly. Maybe tape it shut with duct tape. The drain, that is, not the entire tub. And in terms of radiation removal, probably distillation is your best bet. There are other ways to filter through clay and dense earth. And then you definitely want to purify the water. That will not remove radiation, but you want to purify it, make sure there's no E. coli or something like that, because you don't want to get sick from something else if there are no doctors available to you. And that's about it for water. Other places to look for information would be Nuclear War Survival Skills, Chapter 8, FEMA's website. These links to FEMA water management and ready.gov water management, they don't necessarily focus directly on radiation, but they do cover just general information on that. You can look at FEMA's website, U.S. Department of Agriculture, and so on and so forth. So this has been a part of the 3-part so far. What to do in a nuclear crisis, nuclear radiation emergency information. This information, the author of this information is not a medical physician or psychiatrist or expert in emergency management. It's just a compilation of private research. If you want up-to-date information, you should listen to the media, radio, or television, or call 1-800-BE-READY, 1-800-237-3239. You can find further research at ibiblio.org/rcip/nuclear.html. And there is also a disclaimer at the bottom of the website saying essentially this information is for educational communication and information purposes only and not intended to replace or constitute medical advice or treatments. And the rest of that disclaimer is available at the bottom of the website. Thank you very much and have a good day.